Okay, we're going to look at the pre-calculus midterm review day 2. So starting off with, given the rational function g of x, answer the following questions. So we're looking at these rational functions and first asked to state the domain. Now remember, the domain is where the denominator is 0. Those are our exceptions, I should say. So we want to factor this out. So I'm going to factor the top and the bottom here while I'm dealing with it. And I'm going to say the top is x plus 2, x minus 2, it's a difference of squares, over x minus 4, x plus 2. Now, our domain, like I said, is all real numbers except x cannot be positive 4 and negative 2. Those denominator issues. So it can't be 4 or negative 2. Now the vertical asymptotes are what's in the denominator after you cancel. So since I cancel the x plus 2's, what's left is 4. The wholes are now what you cancel. So maybe I'll make a note here. Left after canceling. And then this is what actually gets canceled. So then the wholes are the negative 2, since we canceled x plus 2. Now, remember, with horizontal or slant asymptotes, I'm going to make a little note off to the side here. This is something you might want to jot down. We had the 3 situations. Situation 1, when the degrees are equal. When that happened, when the degrees were equal, there was a horizontal asymptote at y equals a over b, where a and b are the leading coefficients of the top and the leading coefficients of the bottom. I'm going to abbreviate the leading coefficients. The second situation was when the degree on the top was greater than the degree on the bottom. When that was the situation, we had a slant asymptote, and we found that with the long division, the polynomial long division. Our third situation was when the degree of the top is less than the degree of the bottom. In that situation, it's always a horizontal asymptote at y equals 0. So that might be useful for our slant asymptotes or horizontal asymptotes there, that whole section. So with that being said, we're looking at our degrees here. Well, the degree of the top is 2. The degree of the bottom is 2. Well, since they're the same, it's y equals a over b. Since a is 1, b is 1, both those leading coefficients are 1. It's just y equals 1. Okay, now we need to look at any x or y intercepts. To do that, probably the easiest way is to go on the graph on Desmos. So I'm going to make a note here. I used Desmos to graph this, and I found an x-intercept was at 2, 0. A y-intercept was at 0, 1/2. So an accurate sketch. I'm going to use all the features that I came up with and create a sketch. I have a vertical asymptote at 4. So let me just do a little dotted line for that. I have a horizontal asymptote at y equals 1. I know that there's an x-intercept at 2 and a y-intercept at 0, 1/2. I also know one more thing. There's a hole at -2. So when I sketch this graph, it looks like this approaching that asymptote with a hole at 2, -2, and then the other piece is up here approaching those asymptotes. So the red part is our graph. The next question is find all asymptotes of the rational function. So first we'll start with the vertical asymptotes. Remember, that is factor it, see what's left over on the bottom. Well, the top doesn't factor. The bottom factors into x plus 1 times x plus 1. So we have nothing that cancels, which means we have a vertical asymptote where the denominator is 0. It happens to be the same point on both of those. So let me make a note. The vertical asymptote is -1. We also need to determine, is this a horizontal or a slant? Well, the degree on the top is 3, degree on the bottom is 2. Remember, that means we have a slant asymptote, and we need to do the long division. So I'm going to set up long division here. I'm going to set up my 2x cubed minus x squared placeholder for x, since we skipped it. And remember, it's the 2x cubed divided by x squared. That gives me 2x. Multiply 2x back out in front. So when I multiply it, I get 2x to the third, and then plus 4x squared, and then plus 2x. I took this and I multiplied it out to all three of these. Subtract. Those cancel. Next one is -5x squared. Next one is minus 2x. And I'll bring down the plus 3. Do this process one more time. -5x squared divided by x squared is -5. And remember, we can stop here because we have a linear equation. Y equals 2x minus 5. Next up, we need to write the polynomial in factored form, and I give you a hint to use the rational roots theorem. Remember, the rational roots is the p's and q's. So p's are the factors of this last number, 16. So we know that's plus or minus 1, 2, 4, 8, and 16. The q's are the factors of the coefficient out in front. Just 1. Your p over q are all your possible rational factors that could exist in this polynomial. We just take the top and divide it by the bottom. Well, anything over 1 just remains itself. So really, we have the exact same factors: 1, 2, 4, 8, 16. These are, remember, our possible rational roots or factors. Now, I would either test these. Remember, you can use multiple ways. You can use the factor theorem, where I plug in 1 for x and see if it gives me a remainder of 0. If it spits out 0, it is a rational root. Or you can use synthetic division and divide 1 from that, or you can use Desmos. So Desmos will test on the graph which ones actually exist, and our actual roots for this question, no matter what method you use, you should come out with the same roots to be -4, -2, +1, +2. Remember, those all come from the list that we just created. Now we just need to write them as factors. So our function, f of x has factors of x plus 4, x plus 2, x minus 1, and then x minus 2. And there we go. Next question, they ask, write the standard form of the polynomial p with roots of 3 and 1 plus I. So we need to remember a certain theorem called the complex conjugate theorem. What that tells me is every time I have an a plus bi as a factor, I can automatically assume the conjugate a minus bi is a factor. And that works both ways. If I have a minus bi, then I know it's a plus bi. So that means our actual factors here, or our roots, are 3, 1 plus I, and 1 minus I based on this theorem. So we have 3. This is a third degree polynomial. That means p, let me give myself plenty of space here, equals, I'm going to write these as x minus 3, x minus, we have our 1 plus I, x minus, we have our 1 minus I, and we just need to write the standard form. So distribute everything. This might take a few steps, but I'm going to start with these two here, and I'm going to treat these as 4 parts. 1, 2, 3, and 4. So x times x, x squared, and then the outer, I'm just going to put those together. So it's negative x, 1 minus I. I'm not going to distribute anything yet. The inner, I'm just going to put those together. Negative x, 1 plus I. The last, just going to put those side by side, plus, because they're both negative, 1 plus I, 1 minus I. So that's our second value. Remember, we still have the x minus 3 as the first. Now we can distribute some things in that second set of a large parentheses there. So I know I can distribute that negative x and that negative x. Let's do that. So I have x minus 3, x squared minus x plus ix, and then minus x minus ix. Distribute this with FOIL, 1 plus I minus I squared. Start simplifying. X minus 3. I have an x squared, and then minus 2x. These guys cancel. These guys cancel. Plus 1. I also know I squared is negative 1. That's our property. So minus negative 1 would be another plus 1. Let me just rewrite this as plus 2. And then we need to distribute these, and we're done. So distribute the x to all 3 of these. X cubed minus 2x squared minus 2x. Sorry, that should be, yep, minus 2x. Whoops, that should definitely be plus. And then the negative 3, x squared plus 6x minus 6. Combine like terms. P is x cubed minus 5x squared plus 8x minus 6. And there's our polynomial standard form. Now if we check this, the only root that would show up, it would cross at 3. So it should be able to cross, and it does, at x is 3. Okay, moving on to the rational equations here. So remember, the rational equation, we always want to multiply through by the LCD. So the least common denominator here is going to be, let's see, I see an x, 6, and 2x. So we're going to multiply it all by 6x. That should cancel all the denominators when I multiply through. So I have 5 times 6x over x plus 6x over 6 equals 9 times 6x over 2x. Now we know we multiplied right if everything cancels. So x's are gone, 6's, and then 6x and 2x can be reduced to 3 there. So I have 30 plus x equals 27. So then just subtract your 30. X is negative 3. Remember to check denominator for extraneous solutions. So denominator checks out okay. X equals negative 3. Works out fine. Okay, another example here. We have polynomials, so the first thing we want to do is factor what we can, see if that helps our LCD. This factors into x minus 4, x minus 2, which definitely helps. I'm going to multiply all of this by x minus 4, x minus 2. So my first step, I'm just going to throw all of these in the denominator. If you can skip through this, that's no problem, but I like to write it all out so you can see what cancels. X times x minus 4, x minus 2, all over x minus 2. 2 times x minus 4, x minus 2, all over x minus 4, x minus 2. Canceling. X minus 4 is there, x minus 2 is there, and then both factors there. So what's left is x minus 2 plus x times x minus 4 equals 2. From there we can distribute and solve. So I've got x minus 2 plus x squared minus 4x equals 2. I see a quadratic. Set it equal to 0. We're going to try to factor it. So x squared, combine these to give me minus 3x, and then I'm going to subtract this over to give me minus 4 equals 0. I can definitely factor that. X minus 4x plus 1 factors that. Solutions of 4 and negative 1. And remember, we want to check. When I plug 4 in, and I'm going to highlight the issue right here, that gives me 0. This is what we call the extraneous. Negative 1, there's no issue. That's our only solution. So x equals negative 1. The last bit here on the second study guide was the radical equations. So remember, with radical equations, in the first situation here, since they both have a fourth root and there's no extra on the outside, all we're going to do is raise both to the fourth power, because that cancels our radical. Which means I'm left with x squared minus 10 equals 3x. Another quadratic, let's set this equal to 0. This factors as well. This factors into x minus 5, and then x plus 2. Solutions of 5 and negative 2. Remember, we still want to check. And this one you actually have to go in and plug in the values. Check to see what works. Off to the side, the 4th root of 5 squared minus 10 equals the 4th root of 3 times 5. Well, that's the 4th root of, let's see, 15 equals the 4th root of 15. That one's good. So 5 works. Let's try -2. Equals the 4th root, let me line here, of 3 times -2. So 4th root of, that's 4. 4 minus 10 is -6. Equals 4th root of -6. And that actually works out, since they're both -6 as well. They'll just be imaginary numbers, right? Complex numbers. So both of them are solutions. Lastly, we had a little bit more complex one where you had 2 radicals but then another number that's outside the radical. And an easy strategy, at least the one that I taught, was that we want to isolate the more complicated radical first. So that means I'm going to add the square root of x over and isolate the x minus 6. That should be a -2. It's a little higher. -2. So let's square both sides. Square, square. X minus 6 equals -2 plus x times -2 plus x. So I have x minus 6 equals, let's see, that's going to be 4 minus 2x minus 2x and then plus x. So x minus 6 equals 4 minus 4 radical x plus x, and then we're going to re-isolate the only radical we have remaining. So I'm going to subtract x, and I'm also going to subtract 4. So those x's cancel. 4 cancels, and I get -10 equals -4 radical x. Keep isolating, divide your -4. So that's 10 over 4. I'm going to simplify that to 5 halves equals the square root of x. Square both sides to solve. X is 25 fourths. Square the top, square the bottom. 25 over 4. When you check that, go back to the original equation. That does work out, so your solution in this question is 25 fourths.